I know the answer will be x plus something times x plus something. And I know the two somethings are factors of 24. So I'll list all the factors of 24. Which pair gives me the two numbers I need? The one which not only multiplies out to 24, but also adds up to 11. And that's all there is to it. I can write my answer with the 8 first or the 3 first. It doesn't make any difference. And, of course, I checked my answer by multiplying. And it works. Does this method always work? On the right kind of problem, yes. As long as the problem presents you with 1x squared, which is simply written x squared, you're okay. If it's more than x squared, say 3x squared, you will need to study the module and harder factoring first. At some point, you're going to run into an expression like this one. When you apply our method, you'll find out that it doesn't have any factors, and that's okay. In this case, you're looking for two factors of 1, the last term, which add up to 1, the middle term. You're right. That's not possible. The factors of 1 are 1 and 1, and 1 and 1 never add up to 1. So our method tells you that this expression can't be factored. On the other hand, you'll frequently see problems that look difficult or impossible because the last term is negative, or perhaps both the second and the third terms are negative. Do they represent a special difficulty? Not really. You just have to think carefully about adding and multiplying negative terms. The last term in this example is the clue. What does it tell you? It's negative. You can't be looking for two negative numbers. The product would be positive. So you must be looking for one positive number and one negative number. Just as before, you're looking for two factors of 12. And just as before, they have to go together to make up the number in the middle term. But now you have to search the pairs of factors and make one number positive and one negative until you find the right combination. Which pair of factors combines to give us a positive 4? 6 and 2. Positive 6 and negative 2 gives us a positive 4 in the middle term. And positive 6 times negative 2 gives us negative 12 in the last term. Notice that just as before, we can write out the answer in either order. It doesn't matter at all, provided we keep the 6 positive and the 2 negative. Notice also that if you were given this slightly different problem, there would be a small but very important difference in the answer. You'd still need a positive and a negative number. You'd still need 6 and 2 to give you the 4 in the middle term. But we have a negative 4 this time instead of a positive 4. You'd have to switch the signs and make it negative 6 and positive 2, which we can write in the brackets in either order. If you worry that the order matters, multiply it out both ways and see what you get. This kind of problem is one of the most common in all of algebra. Practice them now until you can do them with ease. It will save you lots of trouble later because you'll need these skills often. You can find more help in your textbook with examples worked out and more problems to do by yourself for practice. Here's one last example that combines the two main ideas of this module. At first, it looks too complicated to solve until we realize that there's a common factor in all three terms, 2x. We make life easier for ourselves by taking it out immediately. That leaves us with a familiar-looking trinomial in the brackets, and that we can handle. We need two factors of 6, one positive and one negative, which will combine to give us a positive 1 in the middle term. That can only be positive 3 and negative 2. So we fill in our answer, remembering to keep our original common factor, 2x. Whichever way we choose to write it, we can check our answer by multiplying it out, and it'll work perfectly. Practice on a lot of these problems right away, and when you're ready, move on to the module and harder factoring.